Today we are going to continue with solving exponential equation. We talked about whenever you have a single base on each side, and then we talked about when you were multiplying two bases, and today we're going to talk about when you were dividing two bases. So if you recall from algebra, we have those exponent rules about dividing two things with the same base. So if I started off with something like x to the sixth, and I divided that by x to the fourth, this turns into x to the 6 minus 4. It's always the upper exponent minus the lower exponent. So this would give me x to the second power. For our equations, it's the exact same concept. So if your bases are the same, you're going to subtract your exponents when you're dividing the bases. So you have to make sure you get this side down to a single base first before you can solve this by just ignoring the bases and setting the exponents equal to each other. So I couldn't just ignore these bases right now and set the exponents equal to each other, because then I'd be in a fraction over here. That's not what we want. So this turns into the 6. The base is not going to change. You take your upper exponent, 2b plus 1, and you subtract your lower exponent, which is negative b. And then the other side was just a single base already, so we're going to go ahead and leave that. So now that we have it to a single base on this side, a single base on this side, our bases are the same as each other, I can go ahead and ignore those bases, because if the bases are the same, the exponents have to be equal. So now I'm going to go ahead and set my exponents equal to each other. So I get 2b plus 1, and then plus b, equals 3b plus 2. And then you're just going to go ahead and solve this. So you're going to combine your like terms. 2b and b is 3b. Try and get your variables all on one side. So maybe subtract 3b from both sides. That cancels. That cancels. So this one we end up with 1 equals 2. You know, you always want to go back and make sure you did everything correctly. Subtracted my bases, or subtracted my exponents here. I've done everything correctly, but I get a false statement and my variables cancel each other out. So this one has no solution. Here's another example. Our bases are not the same, so we need to decide on what base we would like to use. So remember, you're always looking at the smallest base that you see, and you have to try to think if you can rewrite the other numbers in terms of that base. Well, this is a base 9, so 9 to the first is 9. 9 to the second is 81. Well, I've already passed up the 27 if I'm going to use a base 9. So we can't use base 9 here. So you're going to want to go down a base. So I would say to use base 3 then, because I could do 3 to the second power, and that's going to give me 9. 3 to the third power is going to give me 27. 3 to the fourth power is 81. And then 3 to the fifth power equals 243. So the numbers that we have in our equation are 9, 27, and 243. So these are going to be the three bases. I'm sorry, the three expressions we're going to use to change our bases here. Okay, so you take each little part separately. So 243, you're going to replace just the 243 with 3 to the fifth. So we end up with 3 to the fifth. But then we already had this exponent of 3 minus p, so we need to multiply. And then divide by. So now we're going to take and replace the 27 with 3 to the third. Again, we already had an exponent there, so we want to go ahead and make sure we multiply. So it's going to be 3 times p, so this turns into 3p. And then moving over to the other side, equals 9 is going to be replaced with 3 squared. Okay, so now you're ready to solve. You're going to subtract your exponents here to get this down to a single base. Our bases are all the same, so we're going to go ahead and just subtract these exponents. So it turns into a single base of 3 to the 5 times 3 minus p minus this lower exponent, which is 3p, equals 3 squared. And then from there, you have your bases the same, so we can go ahead and just cross those off, because if the bases are the same, the exponents are equal to each other. And then we're just going to solve this. So I'm going to distribute this 5, so we end up with 15 minus 5p minus 3p equals 2. So that's what the exponent turns into. And then you want to combine your like terms here. So 15 minus 8p equals 2. I would subtract 15 from both sides. That will cancel. Negative 8p equals negative 13. Divide both sides by negative 8 for those to cancel. So p equals, this is going to go positive because they're both negative, 13/8. And like always, if you want to check your answer, you can just take that 13/8 and you can plug it back in right here and right here. Okay, so we have one more example. So we're still dividing. Here's our big fraction bar here. So we're still dividing two bases. We want to think about a base to use here. You could try for 36 because that's the smallest number that you see, but if you raise 36 to the second power, that gives you 1296, which is much bigger than 216. So you want to go down a base. So I would say use base 6 here. So hopefully you guys are getting pretty good at this by now. 216 is going to give me 6 to the third power. So I'm going to replace my 216 with 6 to the third. But then I'm going to have to multiply this exponent that was already in the problem. And then that's over. So 1 over 36. Well, if 36 is 6 to the second power, 1 over 36. Remember, when you have 1 over a number, this just means your exponent is going to end up being negative when you rewrite it. That's 6 to the negative 2. Okay, so for our denominator, we're going to change this 1 over 36 to 6 to the negative 2. And then for the other side, 36 is just 6 to the second. And now you can go ahead and subtract your exponents. So we're going to write this side as a single base. So it's 6 to the 3 times the quantity, negative 2k minus 1, minus the lower exponent, which is negative 2. So you want to be careful when these denominators have a negative exponent, or even if it has more than one term. You want to put your minus after your first exponent and then open a parenthesis just so you don't forget to distribute that negative. And now we're ready to solve because we have our bases the same. We have a single base on each side. So now you just solve. I'm going to go ahead and simplify this as I go. So distribute the 3. So it gives me negative 6k minus 3. And then this turns into plus 2 equals 2. Combine like terms over here. Negative 6k minus 1 equals 2. Add 1 to both sides. So negative 6k equals 3. And if we divide by negative 6, k will be negative 1/2. And again, you can always plug that back into your original to check. So, all right, so you guys are going to have a practice day for this, a review day tomorrow, and then a quiz on Friday. Let me know if you have questions. I'm happy to tutor.